Okay, good morning class. So today we're going to learn, not going to learn, we continue to discuss our paper 4, trial exam paper 4. So yesterday we stopped at this question 11, okay? So now I'm drawing the diagram, okay? Okay, this question. Okay, so the question is, oops, hold on. Wait for a while. Okay. So yesterday we stopped at this question 11a part 3. This pentagon has part 2, BC. It tells you that the BC equal to CD. So you want to calculate the angle of CBD. CBD, where is the CBD? CBD. So you need to draw this line, this dotted line, and you are going to find out this angle, CBD, this angle. Okay, CBD. So how are you going to find out this? Okay, we're going to use this information. BC equal to CD. BC, this one equal to CD. It means what? You see, this triangle is an isosceles triangle. So isosceles triangle means what? Their acute angle are the same, right? Their acute angles are the same. So how do we find? Okay, how do we find this? First of all, this angle X we have already found, right? So yesterday we got this angle, the X equal to 118. Okay, you should already know how to find out this angle X. Okay. So now, after you get this, how do you get these two angles? Okay, use the 180, right? In order to get this angle CBD, you just take 180 minus 118 over 2. Okay, then you can get 31 degree. Okay, so the angle is 31 degree. You minus this one, and then you divide 2. Then you get this acute angle of this isosceles triangle. Okay, so this is CBD. So you got this one, 31. Right, now we go to part 3. This is part 2. Richard, you just show the whiteboard only. You don't need to show this one. Okay. Okay, now this. It tells you that this pentagon also has one line of symmetry. Calculate angle ADB. Has one line of symmetry. Where should be the line of symmetry? Okay. How should we draw the line of symmetry for this pentagon? So when you draw the line of symmetry, you need to make sure that both sides of the line of symmetry will be the same. So how should you draw the line of symmetry? So that the left side or the right side will be the same, or the upper side or the lower side will be the same. So how should you draw? It will be like this one, right? This will be the only line of symmetry. Okay? You see, you can try. We cannot have other ways to have other line of symmetry. Okay? This is the only way we draw the line of symmetry. Because this is not the what? This is not the regular pentagon. Remember, you see, all the angles are not the same. So these are not the regular pentagon. You cannot have so many lines of symmetry. Okay, we only have this, and this angle are the same, these are the same. So that's why we can separate this figure into two parts. using this line of symmetry. Two equal parts using this line of symmetry. Okay, now calculate the angle ADB. ADB means what? Here is the angle ADB, right? So how should you find? Do you have any idea? Okay. Now you already get this is 31. Right, this is 31. Here also 31, but right, because this line was because these two parts are the same, right? Because this line of symmetry, this part, the left part and the right part are the same. So seeing this angle CDB is 31 degrees, so the EDA also 31. Now you only left this one. You see, here is the one they want to find out. ADB. This is the question. This is what the question looking for. ADB. So this one. So the total angle here, the angle D is 84. You just minus 31, you get the answer, right? So in order to find the angle ADB, it just simply means 84 minus 2 times 31. So you get 22. Okay, so we settle for this question part A. Now we go to the part B. Okay, part B. Part B. Okay, so I'm going to draw this circle. Okay, this is point O. A, B, C, O. Okay, so this is a circle. Find the value of y. Okay, how do you find the value of y? So you need to apply some of the theorem of this cyclic quadrilateral. Okay, this is what you call cyclic quadrilateral. You should already know this. Okay, there's quadrilateral in a circle, inscribed in a circle. This is what we call quadrilateral inscribed in a circle. This is what we call cyclic quadrilateral. So we need to apply some of the theorem. Okay, some of the theorem of this cyclic quadrilateral. So which theorem should we use? We should use the angle at the center is twice the angle at the circumference with the same arc. Okay, here is what we can do. Okay, we can draw this line. Okay, these two lines. So now you notice that angle at the center is twice the angle at the circumference. In order to get this angle and this angle, you see, this angle is actually smaller than this angle, right? In fact, it is half of this angle, because this angle at the center is twice the angle at the circumference. Means this angle is half of this angle. So half of this angle will be what? This one will be 3y over 2. So that angle will be half of this angle, 3y over 2. Now you got this. Okay? After that, after you get this, how can you relate with this one, this angle B, so that we can form an equation? So how? We need to apply another theorem that the opposite angle of this quadrilateral, cyclic quadrilateral, the total of this opposite angle will be 180. You should already know this, okay? So the sum of this angle and this angle will be 180. Means you take this at this angle, you get 180. 3y over 2 plus 4y plus 4, you will get 300, sorry, not 360, 180. Got it? So this angle refers to angle here. This angle is angle B here. So these two angles, okay, we put them together, you add them together, you get 180. So from here, how do we solve? So you see, here we got a fraction. Okay, you want to remove the denominator. You just need to times 2. Times 2. So when you times 2, be careful. When you times 2, both sides need to times 2. Means every terms you need to times 2. Okay, not only this one, but three of these terms. Okay, 3 terms. These 3 terms, okay, you need to times 2. So that now you can get rid of this denominator, you got 3y. This one, these two terms, you need to times 2, so that this one you get 8y plus 8. This one times 2, you get 360. Now you can simplify it, 11y. This is what we call like terms, right? Like terms we can add together. This one, what do you get? 352. Okay? Now, finally, your y is 352 over 11. Now you got 32. Okay? No degree, because this is just the value of y. It's not degree, just 32. Okay? Yeah, this is the last question, right? Okay, now we're gonna open the new paper. Okay, we're gonna study we're gonna do a new paper. Okay. This is the paper that I already sent to you in the WhatsApp group. Okay, please go to open the paper. Okay, I have already sent the paper to you in the WhatsApp group. This is a paper from 2017, and it's about this is paper 2. This is paper 2. Okay, let me see. Okay, this is October-November paper 2017. Okay, paper 2. Now we look at the first question. Question 1. Okay, here we have this figure. Okay, somehow like this. Should be longer. Okay, should be longer. Okay, like this. You have okay. Okay, so this diagram shows a quadrilateral. You want to find the value of x, huh? You want to find this value of x. So how should you find? So you know that the total interior angle of this quadrilateral will be 360, right? It's just like the total interior angle of rectangle and square. So this is the same. As long as we have a polygon that has 4 sides, then we can, well, you can find out the total interior angle. The total interior angle of this quadrilateral will be 360. So in order to find this x, you just take the, well, in order to find x, you just take the 360 minus 72 minus 83 minus 104. Now you get 101. Okay, so this is how we find. Okay, now question 2. This one. Okay, maybe some of you have already known how to solve for this, but when we solve the question, by the time we solve the question, I also will teach you something more, okay, some extra knowledge, okay, that related to this type of questions. So make sure you pay attention to it. Even you already know how to do this, but please, okay, pay attention to what I'm gonna say, okay, because I will talk something extra, okay, related to this, and which I think is important to you. So make sure you pay attention to to every question that I discuss with you, okay. So now, this one, you see, this, we have a name for this kind of number. We have a name for this type of number. This is what we call index notation. Okay, this is what we call index notation. We have 2 index notation here, and these 2 index notation, we do something on these 2 types of these 2 index notation, right? Using the times operation. Okay, we use the times operation. So when you see that is a time, if you see there is a times symbol here, operator, times operator here, and these 2 are the index notation. And one more condition is that make sure they have the same bases. Here is a 2, here is a 2. Okay, they have the same base here, 2 and 2. Now you can apply the law of index. If the base are the same, then we can do like this. Okay, keep the same base. And you see here, see this power. If this times, we're going to add. We're going to use the plus. Plus what? Plus this power. Okay? It just simply means we combine these 2 base as 1, and then the power, we're going to add them together. Okay? Just like this. If this is times. If this is divide, we're going to what? Minus. Let's say I give you this one. So for this type of question, what you need to do is you keep the same base, and then you take a negative 4. Because this is divide, we're going to use the minus sign. Minus this power 5. And you will get negative 9. This 2 to the power of negative 1. Is it negative 1? Sorry, it's not negative 1. It's 1. Right? So 2 to the power of 1 just simply means 2. Very easy. Okay? 2 to the power of 1 just simply means 2. So this is for the case where the operator is division. This is where the case where the operator is multiplication. If multiplication, you need to add. You see, if division, the power need to be subtracted, right? Okay? So how about like if this operator is plus or minus? So how should we do that? How should we simplify it? Okay. You see, let's say I give you a very simple example. Okay. So for this, just now, this question, you know already, this one, you just add the power. So you get 2. Let's say, if this, I'm going to add. I'll give you a very simple example. Let's say this is 3. I'm not going to use the negative power, okay? Just use the normal positive power, 2 to the power of 3 and 2 to the power of 4. How are you going to simplify this? Okay, so how? If this is x, you can't apply the index law. What you can do from this is do the factorization. Do the factorization. Okay, just do the factorization. You see, you need to find the common factor. Common factor of this number and this number. You see, this you have the common factor of 2, which have 3 2's here, right? 3 2 times together. This you have 4 2's times together. You have this one, you have 3 2's times together. So the common factor will be 2 to the power of 3. Okay, the 3 2's. You can only factorize the 3 2's. 2 to the power of 3. We cannot factorize the 2 to the power of 4 because this is not enough. Right, this is only 3. And this is more than 3, and this is 2 to the power of 4. You got 4 2's here. But here, this one you only got 3 2's. That's why you only can factorize 2 to the power of 3. If you take out 2 to the power of 3, now you left 1. Plus this one, 2 to the power of 4. If you have factorized out the 2 to the power of 3, now 2 to the power of 4 will left only 2. Why? You see, when you do this expansion, 2 to the power of 3 times 1, you get 2 to the power of 3, right? So this one is correct. This one, 2 to the power of 3 times 2. You see, when we use the multiplication, 2 to the power of 3 times 2, you will get 2 to the power of 4. Why? Because you just take this power, add this power, right? So this power is 3, and this power is 1. 3 plus 1, so you get 4. So that's why this one you left 2. You just need to minus 1, right? Minus 3. You take out the power of 3, you minus 3, you get 2 to the power of 1. That's why it's 2. This one, 2 to the power of 3, you take out all of the 2 to the power of 3, you only left 1. Okay? If you take all of these factors, all of these numbers, you take out, you left 1. So from here, 1 plus 2 is 3. 1 plus 2 is 3. Now, you know, this can be simplified to 3 to the power of, 3 times 2 to the power of 3. That's all. You can leave your answer like this. Okay? Of course, you can leave your answer in a whole number. It's okay, but I mean, this come to like, if this is x, if this is x, so you need to express your answer in terms of this, right? If this is 2 is x, right? You cannot show the whole number. You need to express in this form. You need to know the simplification. Okay? So this is about the plus. The minus is still the same. You just change the plus to minus. Clear? So this is something extra. This is not in this question. This is not in this question too, but just let you know, okay, so that you wouldn't forget. Okay, you wouldn't forget about this one. Now we go to question 3. Okay, this question 3. Very easy. Just use a calculator. Okay, this one, you see this question. You want to use the calculator to work out this. So how? Okay, when you press your calculator, okay, how do you press the calculator? You don't press all these numbers at once. You can press the the number for the numerator first. Okay? You can press the number, okay, for the numerator first. 5 to the power of 0.4 and then minus square root of 3. Then you press enter in your calculator. Press enter first. Then you press divide. After you press divide, remember in your calculator to put the bracket, open bracket and close bracket. Okay? open bracket, press 0.13 minus 0.015, close bracket, enter. Then this will show you, your calculator will show you this number. Okay, we show this number. Because this question asks you to what? Write down all the digits in your calculator display, all the digits. You need to show all the digits. Not only 3 significant figures, these all digits. Okay, now part B. Part B, it tells you, write your answer to part A correct to 2 significant figures. 2 significant figures. So how? So remember, you can use a calculator to help you to express the answer in 2 significant figures. If you don't know, okay, then you have to learn. 2 significant figures means you start from the left. 1, 2, right? 1, 2. Then we stop here. But look at the next digit here. You need to determine, you need to identify whether you need to round off or not. You need to see the next digit. Here is 9. If more than 5, you know you need to round off. Now become 1.5. That's all. Okay? 1.5. Now we go to question 4. Okay, question 4. Amber means marked. Okay, question 4. Okay. Richard, can you show the screen? Yeah. Okay, this is a question 4. Look at the question 4. Amber means mark on 5 tests is 80. Her marks on 4 of these tests are 68, 81, 74, and 89. Work out her marks on the 5th test. So in this question, come back to the whiteboard. Okay, in this question, it tells you that what the means mark. Okay, means marks is 80, yeah. And did you know that we have a symbol for the mean? Let's say our data is x, then we just use this bar x. Bar x just means the means, okay, average. This, the meaning of this is mean, okay, mean. So it will be 80. This is how you write the mean. This is a symbol, bar x. This x can be anything. Okay, depend on the data. If you express your data in terms of x, then you write bar mean, bar x. So it tells you that he marks on four of these tests are 68, 81, 74, and 89. So he got 5 tests, right? Amber, she got 5 tests. So she got 5 tests. Okay, 4 of the tests will be 68. See here, we have data 1. 68, data 2, 81, data 3, 74, and data 4, 89. Okay, this one, x file is missing, right? X file is missing. So it's given that x1, x2, x3, x4. X just means the data, first data, the second data, the third data, the fourth data. But the 5th one is missing. The 5th one is missing. That's why we need to work out her marks on the 5th test. The 5th test. Okay, the fixed mark here. So, you see, still remember our average formula, the mean formula. This is the formula for the mean. This symbol just means summation, total or summation, okay? Total of the data. This I represent the subscript. It can be start from 1, 2, 3, 4 until the end, the fifth one. Okay, I just subtract the number of the data. Okay, so this just means you add all the data, right? Bar x here is 80. You know this one is 80. Okay, for this one numerator summation of xi, just take you take the data 68. You add the second data 81. You add the third data 74. You add the fourth one 89, and you add the fifth one. You don't know the fifth one, just x5. You don't know it. If you don't know, just express it in unknown, and then divide it by the total number. How many tests do we have here? How many tests this Amber? This Amber got 5 tests. This Amber got 5 tests divided by 5. Okay, so now you can find the x5. You can simplify this one. Okay, so now you got this is, you can take the denominator times 80, become 400 equal to, this one you simplify it, become 312 plus the x5, the fifth test. So your x5 will be equal to 400 minus 312, there will be 88. Okay? 88. So the answer is 88. Got it? Now, we go to question 5. This one. This question asks you to factorize this expression completely. Okay? You need to take out all the factors out. Okay? All the factors are not only sum, because this is factorized completely. Okay? So you need to find a common factor. You see, we have 3 terms here. What will be the common factors for these 3 terms? Look at the 12x squared. Okay, 12x squared. Okay, it can be 3 times 4 times x times x. So this is for 12x squared. For 15, xy, 3 times 5 times x times y. Okay, minus 9. 3 times 3 times x. See, look for the common factors. Common factors mean what? The factors that means these 3 terms have the same factors. Okay, these 3 terms have the same factors. So for this 12x squared, you have the same factor of these 3. For this 15x squared, you have the same factor of 3, and this also, right? So 3 is the common factor. 3 is the common factor. Okay, how about the next one? Do we have the 4? You see, this 4 is a common factor for these 3 terms? No, because this 4, we only have this factor of 4 for this 12x squared. So we cannot accept for the 4. How about the x? Yes, we'll accept for this one. We have the common factor. Okay, these 3 terms have the factor of x. So this x is the common factor. How about the y? Y, no, only for 15xy. So we cannot accept for the y. So the common factor will be 3x. So we need to take out 3x. Okay, after you take out these 3 and x, what you left here? You left 4 and x, right? So 4 times x is 4x. Next one, you take out the 3, you take out the x. Now this 15x will remain 5y. Okay, for this one, you take out the 3 and the x. Now it remain minus 3. Oh, sorry, this is minus. You have a minus sign here. Okay. So now this is the answer. Okay. Okay, we go to question 6. Okay, question 6. I need you to see the screen. Okay, this one. Okay, Richard is showing this one. Okay. Okay. The diagram shows two sides of rhombus A, B, C, D. You see, from this diagram, you only show you A, B, C, but not for the D. So, write down the coordinate of A. This is very easy. I don't need to teach for this. Coordinates of A, very simple. It's just -2, 3. That's all, right? Now we look at the part B here. Complete the rhombus A, B, C, D on the grid. You need to complete the rhombus. So you need to find out the point D. Where should be the point D? Very easy, right? You just find you look for the symmetry of these two lines, AB and BC. Look for these lines, the symmetry of these two lines. They will be around here, right? Okay, so, show on the whiteboard, okay? Okay, you know that. Okay, this is B. This is A. So this is the rhombus, right? So you got the rhombus here. Okay, you can measure the same distance at this BC and same distance at this AB. You will know the point will be at here. Okay, you find out that this is you just complete that. You just draw this circle. This rhombus. This will be at what? 2, 2. Okay, the point is 2, 2. Okay, very easy. Now we go to question 7. Okay, this one. Yeah, showing this one, Richard. Okay. So, this one. Petra begins a journey in a car. So, she accelerates from rest and at a constant rate of 0.4 meter per x squared for 30 seconds. She then travels at a constant speed of 40 seconds. So, on the grid, draw the speed time graph for the first 70 seconds of Petra journey. So don't be so confused about this data. The information that given by the question. This question is not going to ask you about what the acceleration or ask you to find out some parameter or some speed or acceleration. No. Okay. This question just gives you this information to ask you to draw the graph, and the graph is not that complicated. It just simply a straight line. Okay, you see from this one, she accelerates from rest at the constant rate of 0.4. Accelerate. This is the acceleration. For the speed time graph, if this is acceleration, the straight line will be what? Going up. Okay? It will have the gradient, right? It will have the gradient. Not the horizontal straight line, but you have a gradient. We have a straight line that have the gradient. And that gradient will be positive because you see the acceleration is positive. So we're gonna do what? We're gonna draw the straight line that is moving upward. Okay. Showing a whiteboard. Okay. Okay, we start from, I think this is not high enough. I need to redraw again. Okay, 2, 4, 6. 16. Okay, this is the speed. Time. So it tells you that, okay, constant rate of 0.4 for 30 seconds. So how do you draw the straight line? Okay, first of all, you need to know that this acceleration. The acceleration is the speed over the time. Okay, the speed over the time. So it means if you express this in, you draw this graph, okay, the gradient of the straight line will be the acceleration. So how do we measure the gradient? The vertical height over the horizontal width. So the vertical height here will be the speed. The horizontal width will be the time. The height will be the speed, right? Here the speed. The height will be the speed. The width will be the time. And this must be equal to, it tells you 0.4, right? Okay, so you see here, write another way. So this one acceleration is 0.4. The speed, you need to find out. You don't know the speed. The time is given 30 seconds. From here you can find the speed. Okay? So 30 times 0.4 you get, what do you get? Is 12, right? 12 meter per second. So now you know the height will be 12, the width will be 30. This is the width, this is the height. Width 30, the height will be 12. Here. Here. Here will be the point. So it means we draw the straight line from here until here. So the gradient of this straight line will be the acceleration 0.4. How to find this gradient? You just take the height over the width. The height is 12. How do we know it's 12? Just now we found this speed using this formula. Then you get this 12. And how do we get the width? Because it's given 30 seconds. So we draw it from this origin to this 12. And then, tell you what, she then travels at a constant speed for 40 seconds. Constant speed means the speed doesn't change, right? So we remain at the same number. It's a horizontal straight line for 40 seconds until, you see, 30 plus 4 until here, right? 70. Stop at here, 70. So this is the graph. Okay? Okay, next, we look at the TV. Okay, this one. Richard, are you showing this one? Okay. Huh? So, the diagram shows 3 identical cuboids in a tower. The height of one cuboid is 6.5 cm, correct to nearest millimeter. So work out upper bound of the height of the tower. So, okay, the height of one cuboid is 6.5. This 6.5 is already corrected to nearest millimeters. Okay, but the question asks for the upper bounds for the height of the tower. You see, this question asks for the upper bound. So the height for the one cuboid is 6.5. This 6.5 you need to change to upper bound first, right? Because we want to get the upper bound. We need to get the upper bound for this height of one cuboid. This question 8, okay? Okay, here is the cuboid. This is just a shaded part. Okay, now, it tells you the height, this height. 6.5 cm. This is already corrected to the nearest millimeter. Okay, corrected to nearest millimeter. So 6.5 cm, you say the corrected to nearest millimeter. This is cm, not the mm. You need to change to mm first. Okay, then you can find out the upper bound. Okay, make sure the units is the same as the question they asked. Okay, so 6.5 cm equal to 65 mm. Okay, now what will be the upper bound of 65 mm? Okay, upper bound of 65 will be will be 65.5 mm, right? Corrected to the nearest millimeter. Yeah, 65.5. This is the upper bound. Okay, now you got this upper bound of this height for the one cuboid. Okay, this is for one cuboid. We have 3 cuboids here. The whole thing is called tower. Okay, the question asks for the height of this tower. The question asks for the height of this tower, and this height of this tower is made out of 3 cuboids. So the upper bound for this tower, you just need to take the upper bound of the one cuboid, which is 65.5 mm. Then you times 3 to get the height of this tower. So upper bound of the tower, you just take the upper bound of this one height of one cuboid, 65.5 here, right? Upper bound of the cuboid, 65 mm. You times 3. You got 3 cuboids. What do you get? 196.5 mm. Okay, but when you look at the questions, okay, Richard, go back to the question. Okay, you see, you see the answer that require at the right bottom corner here is in cm. Okay, is in cm. Okay, go back to the whiteboard. Okay, in cm, so you need to change this answer in cm. Okay, so in cm will be 19.65 cm. Okay, so here will be the answer for the upper bound, the height of this tower. Got it? You can correct it to 3SF. Okay, 3SF, that will be 19.73 SF. These two answers are accepted. I mean cm. Okay. Now we go to question 9. Okay, Richard, show to the TV. Question 9. Okay, this is the question. The value of the motorbike is $12,400. Okay, each year the value of the motorbike decreases exponentially by 15%. Exponentially by 15%. Calculate the value of motorbike after 3 years. Okay, be careful with the words decrease exponentially. Okay, so decrease is the most important keyword here. Means what? It tells you what? The rate of the, the rate of what? The rate, right? The rate will be decreased. It will be negative. Decrease means negative. Okay, you should know the formula already. How about, how do we write the formula for the exponent? If we say the value is decreased, or increased exponentially, the formula is always like what? Like this. Okay, showing the whiteboard. Okay, so A equal to P times 1 plus R about N. So this is the formula for the exponent, right, of exponentially. Okay, this is the formula. So how? So as I say, the decrease means what? Negative, right? So you R, the rate. Okay, the rate of this decrease will be 15, negative 15. Okay, the P is the original amount, initial amount. 12, right? P is the initial amount, 12,400. 1 minus 15 over 100. This is the rate, okay? Always over 100. The percentage over 100. The percent over 100. Then this N is 3 years. 3 years. Okay, N is 3 years. So you get the final answer. Okay. I think you can correct this into 3SF. That will be 762. Okay. 7620. 3 SF. Okay, now question 10. Okay. Okay, this is question 10. How do we solve for this without using the calculator? Okay, write down all the steps of your working, give your answer as a fraction in your lowest terms. First of all, you need to change this. This is what we call the mixed number here. We need to change to improper or proper fraction. Should change to improper fraction, means the numerator is bigger than the denominator. So how? You just take the denominator 3 times this number 1, you add the numerator. 3 times the 1 plus 2, you get 5. This one remain as the same as 11 over 15. Okay. What should we do here? Make sure their denominators are the same. Times 5 times 5, right? 3 times 5 you get 15. If it is times 5, the numerator also need to times 5. 25 minus 11 over 15. Now from here, 14 over 15. You got this, full marks, 3 marks. Okay. Now we go to question 11. Okay, we go to question 11. Look at the TV. Okay, this one. The diagram shows a regular pentagon. AB is a line of symmetry. Work out the value of D. Okay, so how do we do this? Regular pentagon, that's the keyword of regular pentagon. It means it tells you that all the interior angle of this pentagon must be the same. Okay, so how do you find the interior angle of this pentagon? Okay, show the whiteboard. Okay, this is B, this is A. Okay, after you find the interior angle for this pentagon, okay, so now you can find the D, right? After you find the interior angle of pentagon, you just divide by 2, right? You get the D. But the problem is, how do you find the interior angle of this pentagon? Okay, you can use the formula of the interior angle. Equal to 180 times n minus 2. You get this one is total, not the interior angle. This is the total of all the interior angles for this pentagon. In order to get the interior angle, you need to divide by n. Okay, to get the interior angle. So the n is just number of sides of this polygon. That will be 5. So 180 times 5 minus 2 over the 5 again, right? This one you will get the 108. Okay, hold on, I need to find out this one. Okay, I need to take my calculator. (180) times 3 over 5. 108. Okay, now you know. Oh, this is 108. 108, 108, 108, 108. Of course, for this also 108. And D is just half of this 108. So D, you just take the 108 over 2. You get 54. Okay. Okay, we settle for question 11. Now we go to question 12. Question 12. You have this data. Is this data, this number, not the data, just number. Okay, you can call this as sequence. Sequence. Okay, sometimes we call it as series. If this is series, there will be some addition or the subtraction for series. But you are not going to learn the series. Okay, you only learn the sequence. Okay, here is a sequence. You got many terms. Arrange from the smaller one to the bigger one, or the bigger one to the smaller one. Is up to the pattern of the sequence. Up to the pattern of the sequence. Now we look at this one. From this list of number, write down a cube number. Oh, sorry, this is not a sequence. It's just number, right? Okay, it's just number. There's no pattern for this one. Sorry, I thought this is arithmetic. Okay, now a cube number. Cube number means what? The number that when you take the cube root, if it doesn't contain the decimal number, means it's a cube number. So 343 is the cube number, because when you take the square of this 343, you have no remainder left, right? You have no remainder left, or you have no decimal number. So this is a whole number. After you take the square of this, the cube root of this 343, you get what? You should get a number, a whole number. Three, 4, 3, 7. If you take the cube root of the 343, you will get 7. Right, that's why 343 is the cube number. If you take this one, let's say cube root of 1 over 3, that will be in decimal, right? If the number is in decimal, means this is not the cube number. Okay, this is how you determine the cube number. Part B, the smallest number. The smallest, which one will be the smallest number? I see that this is in decimal. Decimal very small, right? So I think this is the only decimal, and this is less than 2.1 or 2.5. So I think 0.4 is the smallest. Is this true? I think 0.4 is the smallest. No. Smallest, you also have to look at the sign. Negative. Negative is smaller than the positive. You see, a negative 7 is the smallest? No, again, you see, you got negative 11. So negative 11 will be the smallest. Don't forget about the sign. Okay? A natural number, part C. What do you mean by this natural number? Natural number. Okay? Natural number means, in other words, is counting number. Counting number. The number that you can count. Okay? So it's just like the whole number. Natural number is just like a whole number, but the only difference is the natural number doesn't contain the 0. Okay, natural number doesn't contain the 0. Whole number will contain the 0. But natural number doesn't contain the 0. So means the natural number start from 1. Whole number start from 0. But natural number start from 1. Natural number also we call it as counting number. We count from 1. We always count from 1. Okay, we don't count from 0. We count from 1. 1, 2, 3, 4, 5, right? So natural number, we count from 1 and it must be whole number. So that will be what? So all these negative number will be eliminated, right? All these negative number will be eliminated. This is not whole number. Eliminated. Now you only, this one also eliminated. Now you only left 343. Again, the answer is 343. 343 is a natural number, counting number, or you can say counting number. Okay? Now, question 13. Okay, question 13. Very easy, huh? This one, you take the power times this power, you get m to the power of 10. That's all. This times, not plus. Don't take this 5 plus 2. This is not that case. If for the case 5 plus 2, you'll be like this. M to the power of 5 times m to the power of 2. For this case, yes, you take the power at this power. But not for this one. Okay? This just simply means m to the power of 5. This one, this simply means m to the power of 5 because it's square. Square means what? Time itself again. Time itself again, m to the power of 5. So from here, you know, the power is just repeated for 2 times. So you take the 5 times 2, you get 10. That's why you take 2 times 5, you get 10. Because you see, for here, apply the index law, you know that this power you need to add for the same base. 5 plus 5. If you have so many of these index notation that are having the same base, you need to add all of this power, right? The power are the same, so you just take the multiplication, right? If you add the number, they are the same, then you just take the multiplication. So that's why you take the multiplication. 2 times 5, you get 10. Okay? B. 4. Okay. This one, how do you simplify? Very easy. You just take the common, not the common, just take the number 4 here, you times 5, you got 20. Okay, the numerical number here. Okay, you just take the numerical number 4 times numerical number 5, you get 20. This one, when you times, you see, this one we apply the index law. X to the power of 3 times x to the power of 2, you know they're having the same base, the power must be added. Okay, must be added. So 3 plus 2, you get 5. Y having the same base, the power is 1, you know is y squared. Okay, so this is the answer. Okay, we go to the question 14. Question 14. This question 14 will tell you that D is the point and D So find the coordinate of the point E. Okay, this is the question. Okay, what do you mean by this? Find the coordinate of point E. Coordinate of the point E means OE, right? You know this? Coordinate of the point E. This is what you call the position vector. Position vector is about coordinate. Okay, coordinate of this point E. That will be OE. From O to E, from origin to E. This means using this. When you find out this vector, you will know the coordinate. Okay, you will know the coordinate. So all you need to do is just find out this OE. Yeah? So how do you find this OE? That is the problem, right? How to find OE? How to find this OE? If you look back to the question here, it tells you that D is the point. So you see, we know the coordinate of D, and this tells you the OD, the position vector of D, OD. You know the OD. OD equal to this one. Okay? You can use this, what we call the column vector. This is what you call column vector. Okay, 2, -5. And this is DE, right? Okay. What can we do here is, okay, you can find the OE. Right here, OE. OE just simply means OD plus D. Right? That's all. Right? OE just means OD plus D using the law of vector. This addition. OD plus D. Okay, so the OD will be 2, -5. Plus OD is 2, -5, right? DE 7, 1. And this you will get 9, -4. So here is your answer, right? As I say, you want to find a coordinate of the point E, you just find vector OE. This will be the answer. So when you write the answer, you write this way, yeah? You write this way. This is the coordinate. This is column vector. This is the coordinate. Okay? Okay, I think we stop here. Okay, we'll continue the next question in the next class. So please make sure you watch this video. Okay? So thanks. Now we stop here.